All right, let's go ahead and get started. So, hello and welcome to episode 2 of our reality series. So, I'm Kelsey Woodworth, part of the marketing team here at Smartling, and today we're going to unpack the myths and realities of machine translation quality estimation. And so, while I go ahead and introduce our speakers, go ahead and drop it in the chat where you are joining us from today. I'm here on the fine island of Manhattan in New York City, and so curious to see where everyone else is calling in from today, too. So, okay, speaking today, we have Mei Zheng, our senior data scientist here at Smartling. Mei is a language enthusiast with a quantitative background, and she speaks 3 dialects of Chinese in addition to Spanish and some German. At Smartling, Mei works on R&D projects related to AI, prompt engineering for large language models, and data analytics. So you may have seen her last fall at Taos, where she won the World Readiness Competition. We're very proud of her for that. And additionally, she holds a PhD in electrical engineering from Princeton. And also speaking today, we have Alex Yanishevsky, Smartling's Director of AI and Machine Translation. Alex has been in the localization industry for over 20 years in a variety of roles, and he's written numerous articles for industry journals and speaks all over the world at conferences that you might know, like Gala, Lopeworld, Taos, AMTA, and others. His area of expertise includes AI, natural language processing, machine translation, data mining, and computational linguistics. And additionally, Alex is currently Vice President of American Machine Translation in the Americas, and he holds a PhD in Slavic languages and literatures from Brown University. So thank you both for being here today.
Thank you for having us.
Thank you for having us.
Of course, of course. So quick housekeeping, you can find today's slide deck in the docs portion of the menu. So if you look on the upper right-hand side of your screen, you'll see like the chat, the messages, poll, docs. Slides are in there for you to download. And there's a Q&A tab. As questions come up, feel free to drop them in. There are no prerequisites for today's session, but there will be some technical explanations. Like I said, if you have questions, go ahead and drop them in the chat or Q&A, and we will address them at the end. So let's get started. First, we have myth number 1. And I'm going to launch the poll here. So is 90% quality good enough to publish? Yes, no, or maybe. So please go ahead and answer the poll. Okay. Okay, let's see. Can you see the results, Alex? What do you make of these results?
Yes. So thank everyone for your answers. We see pretty much yes and maybe are running even, with no ahead by about 14%. Right. So actually, Kelsey, if you could go to the next slide. Right. So what we were getting at with this question is really there are a lot of different factors to consider, right? And you see some of these factors that we have on the slide, right? So imagine, as an analogy, imagine a fork in the road where you're constantly taking different choices, and depending on the choice you take, that'll take you to a different place, right? So really the answer to this question, at least we feel, is that it depends, right? And the first fork in the road to consider is, when we're talking about this 90% quality to publish, are we talking about automatic quality estimation, or are we talking about a human evaluation, right? So for example, automatic quality estimation, there's a great advantage to it. It's very fast, it's very cheap. However, it's not going to give you the same insight as a human being would. The downside, of course, for a human evaluation is that they're costly, they take a lot of time, and there's a lot of subjectivity attached to them, right? So Mei, I wanted to ask you if you could perhaps comment both on human evaluation, the scoring mechanisms that are used, as well as some of the other forks in the road here that we mentioned.
Sure. So Alex, I totally agree with you in that the first thing you need to consider is, where is this 90% quality coming from? Is this from a human evaluation, which will correspond to scores such as an MQM score, a DQF score, an AQA score, versus is this 90% quality coming from an automatic score, right? So automatic scores, you have these reference-based scores, such as your good old Blue, Laporte, Meteor, versus reference-free quality estimations such as BLERT or COMET, things like that. What I would typically recommend is if you have the resources to do automatic scoring on all of your contents, definitely do that, and then sample some of those strings for evaluation by human. This way you get a baseline of what does that automatic score corresponds to when a linguist sees it. This way you really know, does that 90%, for example, if it's from an automatic score, does that correspond to 90% in terms of human quality when humans rate it? Or does that correspond to like a 50%? And we really need to also get at where that 10% of strings is failing, because that will affect your decision on whether or not you can publish. Would you agree, Alex?
Yes, I absolutely agree. And I wanted to talk about another fork in the road that we have, which is, and there's a bit of intersection between content type and industry and audience, right? So the example that I wanted to use when we talk about this 90% as this is okay to publish, we're on our way, is imagine different industries, right? If you have a regulated industry like life science, right, medical, pharmaceutical, or financial or legal, 90% in most cases probably is not good enough, right? Because imagine if your credit card company was calling you for potential credit card fraud 10% of the time, right? You probably wouldn't be very happy. It would be very disruptive, and you would kind of begin to lose trust and confidence in such an algorithm, right? If you think about it, you're probably called, they're probably accurate 99.5% of the time, if not higher, right? The same thing for life science industry. If, for example, the comma is in the wrong place, and we're talking about using, let's say, something like a surgical knife, it literally could be the difference between life or death, right? So that's really what industry and the style is very, very important for us to consider. May, I wanted to ask you if you could also talk a little bit of whether we're looking at this at the string level or at the document level, because this plays a fairly big portion as well.
Right, exactly. So even when we're not considering life or death scenarios, right? If we are considering, let's say, the translation of a web page, if that on a document level, if overall that web page conveys the meaning of your original source, but for example, that 10% of mistakes is coming from your headers, for example. Would you then publish if this is a public facing web page where you are facing a lot of audience? So this is something that you have to consider as well. Where is that 10% failing, and how detrimental is that failure to the message that you're trying to convey in your translation?
Right. And another thing I wanted to point out, right, is this idea of different languages. That we may have completely different thresholds, not only for industries, but languages too, right? So, for example, if we're talking about the idea of formality, right, in a lot of Romance languages and Slavic languages, Germanic languages, we really have a U formal and a U informal, right? I know, for example, for Japanese, and I know you were doing research into this, it's quite a bit different. So maybe you could comment on that and how that could impact the sort of scoring mechanism that we would expect in the threshold.
Right. So what Alex is referring to here is the overall style guide, right? Because formality, the voice of your contents falls under, for example, your stylistic preferences. But sometimes it's even more than that. It's more than a preference. It's like, I have to convey this formally, otherwise I will lose my client, right? So in the case of Spanish that Alex is mentioning, where it's not just formal and informal, the word choice really depends on the level of respect that you have to pay to the person you're speaking with, and that depends on the relationship you have with the person, right? If that relationship or if that person is of more senior rank than you at your peer level, or is more junior than you. So, for example, if you are talking with a prospective client, or you have your messages translated directing at your client, you will need to refer to this client in the most respectable voice in that culture. If that's not conveyed, even if all of the meaning in your translation is conveyed correctly, accurately across, that style, when that formality is lost in translation, that can be a make or break for your relationship with that client. Another example I want to touch on briefly is recently I have the privilege of talking to one of our linguists, and I learned so much from her. One of which is, for example, in terms of formality for the Mexican government, right? When they translate medical terminologies, there is a guidelines that you have to translate in terms of all medical terms in the formal tone. But as we know, for the Spanish translation, when you use the formal voice, it pushes you, it makes a distance between you and your audience. So in that regard, it might not incite the right behavior from your target audience when your source or when your translation is directed at asking them to do an action. So for example, for the WHO, when they wanted to tell people about their hygienes and produce guidelines on hand washing and everything when the pandemic first started, the linguists need to decide if I need to translate this formally according to the guideline or informally so that everybody will do the thing. So will do the action of this hygiene. So you have to keep that in mind as well when you judge the quality of your translation.
Right. So what we're seeing here is that there are lots of components that go into deciding what the quality is. For our purposes, for the rest of the discussion, we're going to talk about machine translation quality estimation. And this takes us to the next poll and what these components are and how we begin to evaluate them. So Kelsey, if we could go to the next poll, please.
Yeah, the next myth being that MT stinks. So this next one was a little bit too much to put in a poll, but we're curious to see, drop your grades in the chat and grade this English translation. So with 1 being horrible, 10 being perfect, on a scale of 1 to 10, what do you give this translation? So you can see the translation at the top with the various source languages below. So we'll give everyone a minute to weigh in on that. Okay, Sophia says 5. Anybody else?
Well, okay, I guess as people are thinking about this, what we were trying to get at with this question is hopefully we would see a bunch of different responses, really ranging from very, very good to very, very bad and everything in between, right? And what we're really trying to capture is the idea that human evaluations, they're really subjective, right? One person might grade very, very liberally, and another person may be very strict. So for example, languages that have an inflection, like Germanic languages, Slavic languages, someone might see an incorrect ending and might say, wow, this is tragic. This is really, really bad. This is a horrible grammatical mistake. Another person might say, well, look, it's not so bad because the meaning is carried across. It's actionable. I understand what you want me to do. And I have a word consisting of 10 characters. I need to only change 2. That's a mere 20%, and I can go on my way, right? So different ways of looking at it. Another really, really important thing that we want to focus on here is the effect of the source, because we spend a lot of time talking about machine translation stinks, but what about the source that's a contributing factor? So I wanted to invite you, if you could kind of parse these sentences for us, because we came up with the original, and kind of talk about what may contribute to some problems with MT.
Right. So when Alex and I are picking a source sentence, we purposely picked a sentence that is ambiguous in the source. So as you read the source in English, this sentence is ambiguous because it can be interpreted 2 ways, right? It is not clear whether Dr. Smith was guilty of keeping the snake in the court, or was she guilty of keeping the snake after she caught it from the neighbor's property. So as a linguist, I'm not a linguist, but what I often do when I need to translate something is, well, I need to first interpret the source in what I think is the correct translation. I mean, the correct way of understanding it, and then translate it into the language that it needs to be in, right? So what machine is doing here is pretty much the same thing because it's been trained on text that it has already seen before. So the more likely scenario, the more likely or the more probabilistic interpretation is the route that it will take. So it will go that route, to pick one interpretation and then translate it that way. Here, because we're busting the myth that MT stings, I need to defend MT a little bit, right? So if you look at some of these translations, you see that already in a lot of these languages, the MT engine that we chose to translate this actually did a really good job in conveying the fact that Dr. Smith is a female doctor, right? Because it's not clear from if we just have the first sentence where it's just Dr. Smith without the pronoun she in the second sentence to infer that Dr. Smith is female. But you can see that machine translation has already taken the context from the second sentence and was able to correctly translate Dr. Smith to La Doctora Smith, right? Using the feminine honorific in Spanish, for example. So in this case, what I want to say is when the source is ambiguous and we as human doesn't know or have to interpret, we cannot expect in such a scenario for machine translation to do a better job than us.
Yeah, and that's actually what we wanted to get at as well with this question, because, and we'll talk more about this in a moment about different algorithms for machine translation quality estimation. But the issue is that pretty much the vast majority of them don't consider the source, right? And the source is basically the building block from which we begin with. And May was actually showing examples of a particular MT provider that was, all of them, they were good enough to actually notice, to look ahead to the context of the second sentence, say, Dr. Smith is female, therefore we need to make the appropriate changes in the first sentence. There were other MT providers that we tested that were not as good, right? So what we want to get at here is that source is a very, very important building block and should be considered a feature in machine translation quality estimation, right? So one of the challenges for us who are researching into this question is, well, how do we build models that take into consideration both the source and the target? And I wanted to mention another corner case here, and May have you talk about this as well, is often when we talk about machine translation quality estimation algorithms, sure, we don't mention the source. The other thing that we don't mention is that they are primarily, overwhelmingly based on clean language, right? Mm-hmm. Now, we have situations, they're corner cases, but still, the point being that these algorithms are not perfect. We have corner cases with clients who have user-generated content and actually purposely want profanity to be kept in there because it captures a certain tone, right? And quality estimation algorithms are not able to do that. And maybe you could, I know you were looking into this, if you could comment a bit more on why that's the case before we start talking about the algorithms themselves.
Sure, Alex. Exactly as you say, current machine translation quality estimation models, especially even neural models. We'll talk more about models in the next myth, but just to touch on it briefly, what they do these days is they look at whether or not the translation convey the meaning of the source as closely as possible, and they are trained on these really clean data sets. So a lot of times these data sets are prepared by WMT. There are, they are clean to contain a lot of times no HTML tags, no placeholders. But however, when we are dealing with client contents, we deal with a lot more messier data. And when these type of models sees this type of messy data, it doesn't really handle it very well. So in your case, you mentioned the case of profanity, right? So profanity is very is penalized a lot because when you see profanity words, such models give a very high penalty, so that it doesn't, so that it tells you, hey, this is bad translation. You shouldn't publish this. Whereas, like as you mentioned, when we do have use cases for such a scenario, you can't use these automatic scoring mechanisms for that, and we will need to train very specifically machine translation quality estimation models on each different verticals for very specific content types.
Exactly, and it presumes that we have the data in the first place to train such algorithms, so they can actually give us accurate results. So this is actually a good segue into our last myth, right? As we begin to talk about these different components, the idea that there's one machine translation quality estimation model that will capture everything, right? The kind of this Lord of the Rings comparison, right? That there's one ring to rule them all, right? And unfortunately, that's not the case, right? One of the things that I want to start out this discussion with is because recently GPT, right? Chat GPT, GPT-3, GPT-4, they've been so good, right? It's captured our imaginations as human beings. We have amazingly unrealistic expectations of scoring, right? We see this machine produce content that's amazingly creative. We expect the machine to be like God and to become completely omniscient, right? And we kind of forget, like, it really takes us some effort to remember, wait a second, this is a machine that works on mathematics, on probabilities. It works on very biased and imperfect data to boot, and it has no emotion or understanding. No matter, we can prompt it in some ways or others, but ultimately it has no emotion. So maybe, I know we're going to talk about different algorithms. If maybe you can give a very quick history about the different approaches there are to MTQE.
Yes. So when we talk about MTQE, what modern day people refer to when they refer to MTQE is a reference-less machine translation quality evaluation. So what I mean by that, or estimation, what I mean by that is initially when we start with evaluating the quality of a translation, we start with reference-based metrics. So a metric that everybody in the field is familiar with is the blue metric, right? So in that case, you have the source, and then you have a human who has given you a translation. And then you have the machine generate another translation. You're comparing the two translations to say if what's the difference between this translation that's produced by a machine versus the translation that's produced by this human. And there are a lot of such type of metrics, such as blue, such as meteor, poor, all of them falls under Ngram. So and statistical approaches. So as we mature more, we are now in the phase where people are currently using reference-less machine translation methods. So such methods are, for example, reference-free, where you have just the source and you have the machine translation, and you say, okay, just given the source and this machine translation, can this neural model tell me how good this machine translation is, right? So in this case, I want to break it down in the sense that a lot of these Ngram-based models, you can think of them as giving you a way of finding a textual similarity between your translations. So, for example, when we look at blue, what we're really saying is, well, what's the Ngram difference between the translation that's produced by human versus the one that's produced by machine? I want to make a distinct difference in terms of the tier metric. Here, what we're calling tier is actually an H tier, which is measuring once a machine produces a translation, how much does a human have to edit in order for that string to be publishable. So that is I want you to see to really see that difference, because a human, just given the source, can translate the content very, very differently. But if the human is biased or have seen the original MT, and if the MT is good enough that I just need to fix, for example, 2 characters, that is a very big difference in terms of scoring that we will get from a textual similarity side. So on the more neural-based or reference-free evaluation metrics, what we're looking at are these models that are capturing semantic similarity. So what I mean by that is such type of model are really measuring what is the cosine similarity between these sentences that are pointing in different directions in the vector space. So for example, if we look at the slide, you have these different sentences that are in different languages, right? But we convert them into sentence embeddings, and we can plot them in this vector space. In order for us to find what is the semantic similarity between these 2 sentences, we can calculate their cosine distance. So what we're looking at here is to capture what the textual similarity cannot capture. So for example, if it's just a word choice difference between pretty or beautiful, these 2 words can have a very high error, right? If I correct pretty to beautiful. But because they are semantically the same, this might not change the meaning of my sentence, then I might have a very high score in terms of semantic similarity.
Yeah, and I was going to say where this falls down the other way for edit distance, which is the way we're used to looking at fuzzy matches, is imagine the example between after lengthy deliberations, the jury found the defendant guilty versus non-guilty, right? For a machine, this is only 3 characters, right? You would get a very, very high fuzzy match, and God forbid that you would miss that because it completely changes the meaning, right? So one thing as we head into our questions, right, one of the things that that we'd like to leave all of you with is from our side, when we're looking at how to be fair to the translator, we're looking at all different angles. I mean, imagine a globe that we're basically moving different ways. So we look at semantic similarity, we look at textual similarity, we look at productivity. Also, just so we wouldn't be remiss, again, because LLMs are becoming so much popular right now. Recently, I mean, not even a month ago, Microsoft researchers came out with a scoring algorithm called GEMPA, which is specifically meant for scoring the accuracy of LLMs. So, Kelsey, just in the interest of time, because we may have questions, well, why don't we move over to questions, and we could probably talk a bit more about this then.
Yes.
Yeah, definitely. All right. So let me jump in here to our first question, kind of in this same vein, is maybe Alex, you can take a stab at answering this first, but how do you see MTQE scoring algorithms evolving?
Yeah, so the way I would look at this, and we were kind of mentioning this when we were busting the second myth, again, this is kind of my particular hobby course, is again, the idea that there's no one scoring algorithm that's all encompassing. I would really stress that, right? That in order for an algorithm to be effective, we would need specific data for that domain, for that industry. But where I would like to see it evolve more is really to have source be considered an integral part of influencing the target, and really give appropriate weights where source is not very strong, right, or very ambiguous or complex, that kind of raise a red flag that this may have a deleterious effect on the target. I know, Maeve, I don't know if you want to mention a bit more, maybe from an LLM side, how you see things evolving, how you'd envision.
Yeah, so as I already briefly touched on the history of how these metrics are evolving, right, to where we currently are with all these neural models, and definitely as we move into this new LLM world, I do see more research being done on the LLM side in order to see exactly what is the correlation there, and if it can tackle some of these issues that we are having with more dirty content, such as user-generated content, and such as a lot of these HTML type of contents. Another thing I want to mention is, because you touch on source, I do think that there is a way of incorporating that into LLMs, because it is more adept at some of these more complicated tasks that we have. So what we would like to do on our research end is to see if we can incorporate source ambiguity into our future MTQE mechanisms.
Great. And it looks like we have a question in the chat. Are translators going to use ChatGPT as an additional resource?
I can take a first stab. We very much think so. We believe that there's going to be an evolution from, I think translators in a lot of cases are no longer translators, they're actually post editors. And I think we'll see even a further evolution where I think these post editors will begin to take on some of the tasks of a prompt engineer, right? They'll begin to learn how to actually write prompts in such a way that the LLM will be able to correct the output, right? Smooth it out to a particular style that they need, be it gender, be it formality. I don't know, May, if you wanted to add a bit more to it, because I know those were areas that you were researching.
Yes, so this is a great question, because one of my friends who's an English to Chinese interpreter just called me up recently asking if her career is in jeopardy because of this whole new wave of ChatGPT and GPT in general. Where I see that going is really for linguists, interpreters, and these language models to be co-pilots. So I know Microsoft already launched the concept of co-pilot with the new Microsoft Word, Microsoft PowerPoint, etc. But I really see that's where where it's going, where linguists are still in the driving the driver's seat or the pilot seat if we're taking the flying analogy. But sometimes these models can enable these translations to go on autopilot, and then these translators will just have to make small adjustments in order to make the translation better. Because on the research side, even though we do see a lot of times that these LLMs are very powerful at making corrections to MTs, such as making it follow the accuracy of certain gender and formality, style guides, etc. But sometimes it will also hallucinate. And this is when we need humans to step in and say, hey, this is not an appropriate translation, and need to make further modifications to that.
If I can add just one more point to the kind of the human in the loop and how important it is. I think, having started my career as a linguist, and that's my formal training, I think it's actually a very exciting time for translators, because we're so used to getting frustrated at the MT and saying, why do you get this wrong every single time and you can't learn?
Yeah.
Right? We can actually learn now in real time. We could basically we could influence the machine to give us the output that we want with a proper prompt and at a very, very granular level. So to me as a linguist, it's actually very, very exciting that we can do this.
Great. We have some more questions coming in. So Susan asked, human translation is able to ask questions. This is kind of like going back to what you just said, Alex, but human translation is able to ask questions to clarify ambiguity. Will MT ever get to this point?
I think in some of the question and answer aspects, it depends on how you engineer the prompt to do that. So there are different prompting techniques, which I will be talking about tomorrow, that you can give these LLM models the instructions and certain examples. So for example, if you say, okay, if the source is ambiguous, first we need to do research to see if it can detect that, right? So if is able to detect the ambiguity in that source, then you say, okay, if you detect that, then ask the follow-up questions. And then the human in the loop will then say, okay, this is what I actually meant. And then it will have a stab at the translation. So with a chatbot, with these large language models, you are able to do that. I do foresee that. But this is still research to be done to see how good it can get at doing that.
Yeah, but specifically to kind of second what May was saying, we're talking specifically about large language models. We're talking about things like ChatGPT, GPT-4. This is not something that your Google Translate or Microsoft Bing or DeepL can do, and they can't even do it if you train it, right? So the whole point here is that interaction back and forth with the machine, with the bot, saying, this is ambiguous. Here, let me give you a few examples. Correct this so you don't do it in the future.
Right. I think this is more of a question not of if it can be done, is how good can it be? Like, how good can LLMs do this type of job? And we need to do research to find that out.
Cool. Yeah. So similarly, there's another question. How could we recognize the semantic use of the human versus semantic use of the machine? Would human editing make a difference?
What does that mean?
That means, how can you, if I'm understanding this correctly, how can you tell something, human versus machine, and where does human editing come into play there?
I guess whether it was, if you can initially tell whether it was created by a human being versus a machine, like if I guess that's the way I'm interpreting it. Okay. May, if that's incorrect, I mean, please say so in the chat. I guess May, to me, this probably gets into the question of how can we identify that we gave a prompt, right, to generative AI, it created something and it's masquerading as a human being.
Oh, I see. So we cannot determine whether or not this is actually written by a human or a machine.
Right. How can we determine
how
it?
can you? Yeah. So
is there a mechanism to do so?
Yeah, this is a great question. I don't have an I don't have an answer to that yet. But there are times when I am doing research on it, when large language models will output something that me as a human can immediately pick up and say, this is ridiculous. Because depending on how you tune your model parameters, there are certain times the model will come up with certain acronyms that are not acronyms, certain synonyms to words that means something very different in the context. So I'll just give a very brief example. When I was testing out a text that says like, hey, I'm really excited for the prompt engineering event today, that translation of the word prompt, because prompt in English could mean like prompto, right? Or like prompting something. But right now we're using it as the I don't know, verb prompt, noun prompt, right? A prompt, so that's a noun. Right, so that needs to be kept untranslated, in my opinion. But I don't know how to localize prompts in different languages. By the way, it's a recent word. But the LLMs will localize them into like things like in Spanish, for example, to like immediate or to like prompto, and I think that is something that I can pick up as human. But the semantic, like you said, when we look at semantic similarity, that might not that will be picked up too, because words, how semantic embeddings work is that words are like who they hang out with. So for example, if the words always hang out together, they will be pointed in one space in the vector space. So if you don't ever see, for example, immediate, the word immediate associated with engineering, then prompt engineering and immediate engineering will be very far off in terms of their semantic similarity. So you can to some extent pick that up as an algorithm, but for me as a human, that was a very immediate pickup. I don't know if that answers the question. Sorry.
Okay, thank you. Yeah, people can write in the chat if they need further clarification. But the next question is, what does Smartling offer or plan to offer regarding MT quality evaluation? And is this transparent to customers?
So I guess I would, may I'll start, and please feel free to add. We actually have some quality evaluation underpinnings already in our neural machine translation hub. That one of the components of it is auto select, right? So at the moment it's not transparent to customers. I'll tell you where it's going though. So with auto select, what we're able to do is select from a bunch of different MT providers on a locale pair basis, because we basically take a look at the edits that have been made for each engine, and we know we can calculate what those edits are. And what we basically say is, okay, at this point in time right now, until we calibrate again, for this locale pair, this is the MT provider that's best, right? So that's based on quality estimation. The things that we're actually in the process of building is infusing source into it, an evaluation of the source, as we talked about. But ultimately, where we're heading into, and there were actually recently press releases about this, is the idea of language AI. So not just quality estimation, but basically, if you think of a whole continuum, of a whole workflow, your content lifecycle, we want to be able to infuse AI decisions in all parts of it, right? Whether it's the source, whether how we're picking the resource that we're picking, whether it's editing of the machine translation, or whether it's LQA, right? At every single one of those touch points, we want to infuse AI algorithms. I don't know, if you want to add a bit more.
Yeah, something on our research roadmap is to address, for example, the question of what is human parity, right? So a lot of times these MTQE algorithms, even current state-of-the-art, off-the-shelf MQE algorithms, they have about, I think at best 50 to 60% correlations with human direct assessment scores or human evaluations done by MQM. So in that case, we are already at the state of the art, because we have these neural architecture models that we train on our internal data that produces a score, right? And when we correlate it to our edit distance, we are achieving similar state-of-the-art what we currently can achieve with these neural network models. But we don't think that is good enough, and hence the lack of transparency to clients. But what we do want to move forward on is really address the issue of what does it mean to have human parity, right? Does it mean that if in the translation and the post-edit step, if a human, for example, has to make X amount of correction, and that amount of correction corresponds to what the type of the level of edits that a human would make if the translation was first given by machine translation, should that be the definition of human parity? I think what we're addressing here is a greater question of first tackling. Let's define first what is human parity, and then move on to the algorithms that we will develop here to address that. But that is on our research roadmap.
Great. Thank you. That is all of the time that we have today for questions. So those of you that we didn't get to, we will follow up with you. And again, this session was recorded. We'll be sending that out today. But thank you, everybody who attended. And thank you again to Alex and May for speaking. So we will see you guys next month for episode 3.
Thank you, guys.
Thank you for having us.
Bye.